This is Geometry Semester 2. It's the 4th unit called Conditional Probability, and it's abbreviated. Sorry about that, but there's only so much space to fit in on that line. And it's Conditional Probability. It's the second lesson, Combinations Practice. It's on creatormath.weebly.com under the Geometry tab. Copy the following problems 1 through 14 into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So this one, because it's statistics and we're in a geometry class, I'm going to literally go to the website creatormath.com and let's just go back through this. Make sure, let's go to the home page so you can orient yourself. Make sure when you're looking for this website, type in creatormath.com or creatormath.weebly.com into Google and it should get you to this place. You're going to know it's the right site because of my geeky photo on there, right? Which I'm fine with being a geek because that's what I like to be. Now, this is geometry, so you're going into the geometry tab. Scroll past the vocabulary down to the table of contents. Make sure you're in the right semester. For this one, it is semester 2. It says table of contents. This is not trig. It's not special right triangles. It's not constructions and volume. It's conditional probability. Bingo. And it's the second one here. Second lesson, combinations. It goes on page 83, 84. Here are the notes. These are the notes you copy into your comp book on those pages. Sometimes mine does take a second or two to load. Did you see that? It went from sort of blurry to clear right there, and now I can expand it open and see all the notes. So this is talking about conditional probability number 2, combinations and permutations. We definitely want to look at these definitions. Combination, drawing out a smaller group from a larger group, and order is not important. That's a lot of words, and you're going to see what it means as we go through these problems. There is a formula for calculating combinations. It's n factorial over parentheses n minus r n parentheses factorial times r factorial. What is a factorial? Factorial is a math function that tells us, do we have an example of one here? We got vocabulary, permutation. Well, it's this. Let's say it's 5 factorial, right? 5 factorial. And that is an exclamation point, by the way. But it's not English class, it's math class. So what does this equal? This equals 1 times 2 times 3 times 4 times 5. If you had, say, 4 factorial, that would be only up to 4. 1 times 2 times 3 times 4. We'd be done. And you multiply all these and you get a number. And we'll do that as part of our work right now on these problems. Right? So for the following, state if it's a permutation position with repetition or a permutation position without repetition or a combination. And all those words will start to make a little bit more sense as we go through these. They're very complicated, and if it's your introduction to statistics inside of geometry, it can be quite challenging. So let's read the first one. The order of selected items matters, but there are no repeating items. So going back to the notes, permutations. Do they explain to us these different? We have a combination. We have a permutation, which stands for position. So the fact that they're saying selected, the order matters. That's what they mean by position. So this is already a permutation. There are two types. There are without repetition and with repetition. This one says no repeating items. They're just telling us it's without repetition. So it's a permutation without. Keep going and the words might make a little bit more sense as we go forward and keep repeating them. So for the following, state if it's a permutation, which stands for position, just remember the P's match up, with repetition, a permutation position without repetition, or a combination. 3 things we're dealing with, right? Only 3. So it says the order of selected item matters. Anytime that the order matters, it's a permutation because it deals with position. And there are repeated items within the order, so we're going to say with repetition. So a permutation with repetition. Again, we're probably using the notes to help us through this, and I'm getting a little bit fast and fancy here, but I'm going to let you put these notes in your comp book first, and please use them as you're going through these problem sets. Number 3. State again, they want to know if it's a permutation, which deals with position, the order matters, with repetition, permutation without repetition or a combination. The order of selected items does not matter. So see this right here? If the order doesn't matter, it's not a permutation. You only have one option. It's a combination. And we're going to do some problems where we deal with that here in a minute. If the order selected items matters, so now I know it's a permutation, but the items don't repeat. Now it's a permutation without repetition. What's the formula used? This is just asking us to literally read the notes. If it is a permutation right here, permutation without repetition, which is what they're asking us, it's n factorial over n minus r parentheses factorial. So n factorial over n minus r parentheses factorial, where n objects are taken r at a time. We're going to explain that in a second too. Just hang on to that formula for a moment. If the order matters, if the order of selected items matters, so I now know it's a permutation, and the items repeat, it's a permutation with repetition. That's what repetition means, to repeat. What's the formula? It's not this prior one we did. It's the other one. The other one, looking at our notes, which we're going to use to help us. Scroll over here. Here it is, a permutation without repetition. Come on. And, oh, I'm reading it wrong. If I could just read. I was about to say that's wrong, but I read it wrong. Permutation with repetition position. So here it is, n factorial over repeat 1 factorial, repeat 2 factorial. I'll show you what that is in a minute. Okay, so this formula right here. Let's keep those in mind as we go and do a few problem sets. Number 6. If we are selecting a group of objects at a single time out of a larger group, and that sounds an awful lot like a combination right there. That's sort of the short definition of a combination. And are not concerned with the order, so it's not a permutation, then we are dealing with a combination. And so they're already telling us that what we thought was true is right. Another way to think of combinations is that we are selecting a smaller group out of a larger group. What's the formula? For a combination, this is the formula, n factorial over parentheses n minus r factorial times r factorial. Let's see, combination. Here we go. A combination, we're drawing a smaller group out of a larger group. We don't care about position. Here it is right here. NCR is the notation, and here it is, n factorial over n minus r factorial in a parentheses times r factorial. Right? Factorial is spelled, just write it here, factorial. Like this. And sometimes I'll say it, I'll get sloppy in my language, I'll say factorial, and it's not right, it's factorial, all right? Just to give you a heads up. Let's do the next one. What are the number of permutations of 8 objects taken 3 at a time? So now they're giving us this setup like this. They're saying 8p3, and they're having us fill this in according to this formula. In other words, how many different orders can 3 items have when selected at a single time out of 8 total items? Hint, here's the formula. So it's going to be 8 factorial, just filling in, which is n factorial. N is put here, npr, divided by, parentheses, n minus r, which is 8 minus 3, factorial. And, right, here it is. And notice they even did the math for us, 336. You're going to definitely want to go and reproduce this. Bring open your calculator, clear this out, turn it sideways. Let's turn it this way, maybe it's a little bit easier to see. All right. Why do we need to turn it sideways? Because notice what you're looking for. You don't want to do those, like, if 5 factorial is 5 times 4 times 3 times 2 times 1, 120. I don't want to type that all the time. And that's great, because if I go to my first second, okay, somewhere I got it. Here it is, x factorial. See that? So all I need to do is go 5 factorial, and it'll tell me 120. It'll do all that math for me. That's the point of this whole idea, right? So this that function, of having that function. Clear this out, and let's do 8 factorial right here, divided by parentheses 8 minus 3, parentheses, and now we put the factorial on the parentheses. 336, check, check. All right, I want you to run through the math as part of this whole thing and use your calculator. Practice. It's telling you the answer. Go ahead and practice. You've got this video to watch to help you to get it right as you type it in. All right, given the word mom, the order matters and the M's repeat. If the 3 letters mom, M-O-N, M-O-M, are selected from a larger group, it is a permutation without repetition. Technically, the M's could be reversed to provide 2 selection options, but reversing of the M's does not matter because both produce the same effect. Therefore, we say that the M's can repeat up to 2 times. So an M could be here, or an M could be here, or an M could be here, and an M could be here. That's the 2 repetitions. We use a special formula to deal with this special situation of permutation. Reputation, which is n factorial over repeat 1, repeat 2, repeat 3. Mom is not a very exciting example. Mississippi is one of the better ones. We're going to do that next. So follow along with this one. We're going to plug in, how many letters do we have? 1, 2, 3. So we have 3 factorial, that's n factorial, over the m, which repeats twice, so 2 factorial. How does this work on our calculator? 3 factorial divided by 2 factorial. 3 is the answer. And here it is here. 3 factorial divided by 2 factorial is 3, because there are 3 letters in the word mom and 2 repeats of the letter M. The answers aren't hard to get right here. That's not what they're testing us on. They're trying to give us a clue of how to do these and figure through some problems to warm us up a little bit. Right? So how many permutations are there in the state name of Mississippi? M-I-S-S-I-S-S-I-P-P-I. Well, there's 11 letters in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11. And the S's repeat 4 times. The I's repeat 4 times, and the P's repeat 2 times. So we're using the same formula for a repetition, right, for a permutation here that does repeat. That's n factorial over repeat 1 factorial times repeat 2 factorial times repeat 3 factorial, etc. We have 11 letters in Mississippi, so it's 11 factorial divided by 4 S's, so 4 factorial, 4 I's, so 4 factorial, 2 P's, right there, so 2 factorial, right? It comes out to 34,650 options because there are 11 letters in the word, 4 repeats of S, 4 repeats of I, and 2 repeats of P. Let's do it on the calculator. Okay, focus. All right, we're going to type this in. We're going to type in 11, let's clear, 11 factorial divided by parentheses 4 factorial times 4 factorial times 2 factorial, parentheses close, 34,650 times right there. Please put this calculation into your calculator. Even though you already know the answer, you're trying to mimic the same result and see if you can type in those numbers. So this one here, we're circling this whole first option, option A. 10. If we are selecting a group, of objects at a single time out of a larger group, sounds like a combination, and are not concerned with order, definitely a combination, then we are dealing with a combination, and that's the name of this procedure, right, this statistics procedure. Another way to think of combinations are that we are selecting a smaller group out of a larger group. What is the number of combinations of 3 objects taken from a group of 8? So we have 8C, 3 equals, and here's the actual formula for it. N factorial over n minus r factorial times r factorial. Right? Let's go over here. 8 factorial, that's on top. 8 minus 3 is the n minus r, and the whole thing is in parentheses factorial, times r, which is 3 factorial, the ones we're drawing out. 8 is the total, r are the ones we're drawing out. Here's a setup, and I'll explain that in a second. Let's see if we can put this in the calculator and see if we can get this 56 right here. So we have 8, clear? 8 factorial divided by parentheses 8 minus 3 and parentheses right here, then factorial on the parentheses. So 8 minus 3 is 5 factorial, which is what you see right here, 5 factorial. And times, now you got to be a little careful here. I can't say times right here unless I use a parentheses on this whole denominator. See how this is still in the denominator, this times 3? I'm going to say divided by again because it's still this 8 divided by 3 factorial. 3 factorial. 56 right there. There you go, check. Right, so that's your answer, and you're trying to mimic that in the calculator. You're going to struggle. Let me just show you the other understanding. If you didn't use divided by right here, you want to use times. It changes the answer, but why? Because we need a parentheses here and a parentheses here. Now it gets back to 56. So if you're going to use times, make sure that you're enclosing this denominator in a set of parentheses to make sure it's a single unit down here. So 8 divided by this whole single unit. All right, 56. Let's do 11. How do we say 5 exclamation point? This could have been one of the first problems maybe to help us out, but we already know how to say it. And how do we calculate the value? We say 5 factorial, and it's 5 times 4 times 3 times 2 times 1. And you can plug it in to get the 120 like we did. You can just say 5 times 4 times 3 times 2 times 1. Right in order, 120. Or we can use the quick key and just say 5 factorial, 120. Oh. All right. 5 factorial divided by 3 factorial reduces to what? Well, let's write them out. It's 5 times 4 times 3 times 2 times 1. Okay, divided by 3 times 2 times 1. And I purposely lined these up, right? Anything over itself becomes 1, 1, 1. What's left? 5 times 4, or 20. Right? So here it is here, 5 times 4. And it would have been nice to say 20 here. Maybe I can remember to do that on a future one. For the following state if it's a permutation, position with repetition, without, or a combination. We are choosing a smaller group from a larger group, and order is important with no repetition. Anytime order is important, look back at the notes, we're dealing with a permutation, so it's going to be a permutation without repetition. Permutation without repetition. For the following state, if it's a permutation with repetition, a permutation without repetition, or a combination, we are choosing a smaller group out of a larger group, and order is important. Anytime order is important, it's a permutation. And here it says, and there is repetition. So it's a permutation with repetition. Okay. So again, you're matching up the title of this on creatormath.weebly.com. Creatormath.com. It's geometry, it's semester 2, it's the 4th unit, conditional probability, and it's the 2nd lesson, combinations practice.